Okay, welcome back. Today we're going to start Unit 7. And Unit 7 is about systems of equations. So today's video is an intro to systems of equations. We're going to talk today about what is a system of equations. What are they like? What are they all about? And we're going to start to talk today about what it might mean to solve a system of equations. Now, we've already talked about how to solve an equation, a regular equation, like this. This isn't a system of equations, this is just an equation. And if I asked you to solve this, I hope the answer would be yes, you can solve this. And I think you probably can see pretty quickly that x would equal 4, because 4 plus 2 equals 6, right? Easy. That's a simple solution, a simple equation. But what if I made it more complicated by taking that 2 and turning it into a y, and now instead of x plus 2 equals 6, we've got x plus y equals 6. Well, would x still equal 4? I don't know. Maybe. But x could also be 3 because 3 plus 3 equals 6, so maybe x is 3 and y is 3. Huh. But wait a second. Couldn't it be 1 plus 5 equals 6? Couldn't x be 1 and y would be 5? Because 1 plus 5 is 6? Well, that would work too. What if x was 6 and y was 0? Wouldn't that make it a true equation as well? But then wait a second, y is the 6. Couldn't they be switched around? And wait a second, couldn't I just keep up with coming up with, couldn't I just, oh no, there's a whole bunch of different ways you could solve this. And I don't know what the actual solution is. What's the real solution here? I have a bunch of ideas of what it might be, but how do I know what x and y actually are? The problem here is there's not enough information. This one equation doesn't tell me enough to know for sure what x and y are. I need more information. Okay, we need more than one equation to help give us clues about x and y. And so when we talk about systems of equations, that's what we're doing. Here's an example of a system of equations. Let's say I had two numbers in my mind, and I told you those two numbers add up to 9. But then let's say I also told you that the second number, y, was equal to the first one plus 1. What if I told you that x plus y equals 9 and that y equals x plus 1? Now I have more information about x and y. I have more clues to help me solve this problem. When you have two equations together and there's two different variables to solve for, that's a system of equations. So let's write that down. A system of equations is when you have two equations and two variables. Okay, you could actually have a system of equations with 3 equations or more, and you could even have more than 2 variables, like an x and a y and a z, but don't worry, we're not going to get that crazy. Okay, so what is a system of equations? A system of equations. Okay, now what if we had to actually figure out what x and y equal here? Well, I could take the first equation, and I could figure out some ideas of what x might be and what y might be. For instance, maybe x is 0 and y is 9. Hopefully you understand the parentheses there. I'm just kind of using that to give an example of what x and y might be. They might be 0 for x and 9 for y. Because wouldn't that add up to 9? Well, doesn't 1 and 8 also add up to 9? And 2 and 7? That the x is the 5 and the y is the 4? Could be 6 and 3, could be 7 and 2, could be 8 and 1, could be 9 and 0, and we just finished the, oh no, wait. There could be even a whole bunch more than that, because what about negatives? Couldn't it be 10 and negative 1 to add up to 9? Okay, there's a whole bunch of possibilities here, but I hope you see that in order to figure out which one is the actual solution, we have to look at the second equation. So, check out this last possibility, 9, 0. That would mean that x would be 9 and y would be 0. And it can't be that because 0 doesn't equal 9 plus 1. So it can't be that, and it can't be that solution. Maybe it's one of the other ones. So you could try, I don't know, 0 and 9, and you could try plugging those in. If I plug 0 in here, and I plug 9 in here, does 9 equal 0 plus 1? Oh, shoot. Nope, that doesn't work. So we're going to cross that one out. And I think if you kept on testing them and testing them and testing them and testing them and testing them, you would find that a whole bunch of them don't work. And you could test them yourself, like plug in a 3 for x. 3 plus 1 is not 6. Okay? And you could test, and eventually what you would figure out is that 4 comma 5 is the only one that works, because when you plug a 4 in for x, 4 plus 1 actually does come out to 5. Therefore, 4 comma 5 is the solution. It's the actual combination of numbers that works for both equations. Okay? So, the moral of the story here is to solve a system of equations means to find the values of x and y that make both equations true. They don't just make the first equation true, they also have to make the second equation true, and that's how we narrow down our choices and actually figure out what x is and what y is. So it's kind of like detective work here, where you're trying to pin down your suspects until you solve the mystery. Okay? Now don't worry. Later on in Unit 7, we're going to make this an easier process so that you don't have to make a huge, gigantic list and then test them all. But I want you to understand that solving a system of equations means to figure out what x and y are that make both equations true. Okay? So, here's an example. Is 4 comma 2 a solution to this system of equations? 2x plus y equals 10 and x minus y equals negative 7. Well, the only way to find out for sure is, let's take the x, plug it in for x, right? 2 times 4 would be 8, and if I plug the 2 in for y, would 8 plus 2 equal 10? Okay, that works. But it also has to work in this one, right? The solution has to work for both problems. If I put 4 here and 2 here, 4 minus 2 does not equal negative 7. Boo. So is 4 comma 2 a solution to this system of equations? No, because it doesn't work for both equations. It only works for one of them. So we got to try something else. Is 1 comma 8 a solution to this system? Let's try it. If you plug 1 in for x, you get 2 times 1, which is 2, plus plug 8 in for y. Okay, that works. That comes out to 10. Now, if I try 1 here, I'm going to get 1 minus what? 1 minus 8, right? What's 1 minus 8? Negative 7. That works and that works. So is 1 comma 8 a solution? Yes, it is, because the solution has to work for both equations. All right, I think it's your turn. Try this practice problem. Is negative 1 comma 2 a solution to the following system? X plus y equals 1 and x minus y equals 4. Give you a little clue. Can I give you a hint? Remember, this first number is supposed to be the x number, and this second number is supposed to be the y number, just like when we were plotting points on a graph. Okay? So, when you plug numbers in for this x, you're going to use the negative 1. Okay, that's enough of a clue. I'll let you try it. And then we got one more practice problem. Your second practice problem is, I want you to try to just use mental math. Okay? In other words, just see if you can figure this out in your head. I don't want you to spend an hour on this. I don't want you even to spend 10 minutes. Just take a couple minutes and see if you can figure out numbers that would work here and here that would also work here and here. Okay? So see if you can figure out what x is and what y is so that both equations are true. My clue for this is, remember that x plus y has to come out to 30. So your answers here and here have to be two numbers that add up to 30. Maybe that gets you started. It could be 1 plus 29 equals 30. It could be 2 plus 28 equals 30. Then you just have to test them and see if they work here. You might be able to do that pretty quick. But if you can't, don't worry. Okay? We're going to spend the whole rest of Unit 7 finding strategies and methods and schemes to help us solve systems like this without having to rely on mental math. I'm going to give you real strategies, real methods that you can use that'll make it much easier so you don't have to do it in your head. Okay? So you can try that problem. Make sure you get both practice problems done. And that's all I got for you. I'll see you tomorrow.